So let's just focus on the differences between direct proportion and inverse proportion. If we say that something is directly proportional to something else, which also can just be written as something is proportional to something else, so we don't actually need to write this directly here. But if we say that A is proportional to B, or A is directly proportional to B, it means that if I double B, then A would double, or if I double A, then B would double. Again, if I triple B, A would triple. If I half B, A would half. Okay, so in a way, you can say it's whatever you do to B, then the same would be done to A. However, that is only for timesing and dividing. So if I added 3 to B, for example, I wouldn't necessarily add 3 to A. It's only about timesing and dividing. So now the other thing we can do with direct proportion, and I'll use the video, use what I did up here. If you want to just follow me on the board. So this is the example we did originally. X is directly proportional to Y. As we can see in the table here, as when X went from 2 to 4, in other words, it doubled, Y went to from 5 to 10, which means it also doubled. They're not the same. We can see that when X is 2, Y is 5, and when X is 4, Y is 10. So they're definitely not the same. But if I do one thing to X, then I will do the same thing to Y if we're talking about timesing or dividing. So we can, just to show the dividing thing, let's imagine I went from 4 back up to 2. Then in this case, I'd be dividing by 2. And when I do that, Y went from 10 to 5. So again, that divided by 2. Or I can times by 4. If I went from 2, it'd be times by 5 actually. If I went from 2 to 10, then I'm timesing it by 5. And when I times it by 5, I go from, on the Y side, I go from 5 to 25. And again, I'm timesing it by 5. So whatever I do to one, I do the same to the other, if we're talking about timesing or dividing. So that is when X is directly proportional to Y, or if X is just proportional to Y. You also get this kind of graph, which is a straight line, and it goes through the origin. Okay. So, and you can actually come up with this equation: Y is equal to Kx. I explained all of that in a bit more detail in another video, which is probably one of these two. Looks like I'm not sure which one it is actually. Hang on a second. Okay, so basically you can say that if something is directly proportional, then we can say that Y is equal to a constant multiplied by X. And then sometimes you just need to find out what that constant is, which we call K. What is the value of K? So with this example here, we're looking at this table. We take a situation when X is 2, Y is 5. And we write down, well, we know the form, because it's directly proportional, we know that Y is going to be equal to some constant multiplied by X. If we put in place of Y, the value for Y, and the same with X, so let's use a highlighter to show this more clearly. So here's my value for X. There's X, and there is, and I'll just switch these two around. Instead of writing K2, which is a bit confusing, I've written 2K, but KX, XK, it's the same thing, right? So, and then here's my value for Y, which is there, and I've put in that in instead. So then what I did is I rearranged, because we're doing this to find out what K is, so I rearranged it. So I divided both sides by 2. So on the left-hand side, we have 5 divided by 2, and on the right-hand side, we just have K, because 2K divided by 2 is just K. And I have K, 5 over 2 is equal to K. In other words, K is equal to 5 over 2, and 5 over 2 is 2.5. So we have our value for K, 2.5. Y is equal to 2.5x then. because y is equal to kx, and we now know what k is. We could use that to find out a different value for y if we knew a value for x. Or we could rearrange it to find a value for x if we knew what y was. So that's what we did when we looked at the first lots of questions. So when we did workout 1, and we haven't done, looks like we haven't done question 5 to 7 yet. So we might want to have a look at that together as well. Now, inverse proportion is, I think I talked about it over here. Well, one way we could say it is if x is inversely proportional to y, so this is direct proportional here. I wrote that down when I was teaching it. Let's get rid of that now, because that's confusing. If x is inversely proportional to y, then we can say that x is directly proportional to 1 divided by y, like this. And then we could rearrange it, and we see that x therefore is equal to k over y. And so we can find k by multiplying both sides by y. K would be equal to x times y. And if I knew that, for example, when x was 5, y was 2, then k would be equal to 5 times 2, which would be 10. And then I said, well, what is x when y is 4, for example? Well, I have my equation for x, which is 10 over y now, and I put the value for y into the equation, right? So let's just use a bit of highlighting again. Here's my value for k. I worked it out because we know that k is equal to x times y. Here's x, here's y, 5 times 2. So there's my value for k. Okay? And this is inverse proportional now. Okay? So here's x. Here's my example value for x. We don't know what x is yet. We're trying to work it out in this part of the question. But we eventually got it there. And here's y. So in the first situation, y was 2 when x was 5. That's how we found out what k was. And in the second situation, so what we're saying is, in the first case, when x is 5, y is 10. But what is x when y is 4? So we've got now y is 4. So we use the equation x is equal to 10 over y. X is equal to 10 over 4. 10 divided by 4 is 2.5. So that's our value for x. So that's basically the kind of thing that we were doing in these questions. Where are they? These questions. Okay, questions 1, 2, and 3. Okay. Now, one other thing that they sort of like to highlight in inverse proportional is that when you do one thing to x, the opposite happens to y. So if x doubles, then y halves, and vice versa. If y doubled, then x would halve. Or if x multiplies by 3, then y would divide by 3, and so on. But once again, it's only to do with times and divide. It doesn't work with adding or taking away. So let's just look at one of the examples that we did for inverse proportion. And by the way, when you're watching these videos back, you can always pause them, make some notes, or have a go at some questions, and then rewind it, watch it again if needs be, or watch the next bit, however you want. That's the advantage of having it on video as opposed to having it live. So you got it both now. Now, so we've got, looks like I wrote this looks like my handwriting. T is so it says that t is inversely proportional to n. So t is therefore equal to k over n. So k is equal to t times n. So I just multiplied both sides by n. And we've got our, so therefore k, let's use a bit more highlighting here. We've got n is green. So we have, there's the value for n. There's the value for t. And we'll use my blue for k. So we find out k is equal to 30 times 5, which is 150. So that's our first situation. And that's our, then we put it back into the equation here. So this would be this would be part A. So t is equal to 150 divided by n. You don't need to do any of this highlighting. This is just something that you could do, so as you can more easily notice which number refers to what letter. Okay, it's only to try to make it clearer for you. And then we have to find out what is t when n is 10. So we've got our equation now. There's our k. And instead of writing n, we write what n is, which is 10. And we're trying to find out t. So it's 150 divided by 10, which is 15. And then we have work out a value for n when t is 25. So now we have to rearrange the equation. Well, if we start off with t is equal to 150 divided by n, I think what we've done here is correct. We're going to multiply both sides by n, then divide both sides by t. So we when we multiply both sides by n, the n comes up over here. So there's our t, there's our n, and this is our k. We actually already had this, didn't we? Because we know k is equal to t times n, so t times n is equal to 150. We did that there. And then we divide both sides by t. And we end up we have an equation now to work out what n is in terms of k and t. So now we sub in the value for t they've given us. We divide k by the value for t, and we have our value for n. So that's what we did over and over and over again over here. And then we have, I'll check after the video. I'll check to make sure these are correct. But then we had to fill in this table. So actually I will do a little bit of this on the video. As we know, when we double one, the other one halves. So as we went from 16 to 8, then y must have doubled, which means what would y have been before when x was 16? Okay, have a think about that. And then here, y doubles, so x must have halved. So what is x going to be at that point there? Okay, I'm going to pause the video and see if you can work out what that is. Okay, yeah, exactly. So in this table, the x is repeatedly halving. How did we know it's going to repeatedly halve? Because we just look at this middle value here, and we go from we look at y. Y went from 10 to 20 in this second, and if we compare the second and third column, y went from 10 to 20, so it doubled. So x would have halved. We can go backwards to work out what happened to y. So x went from 8 to 16, which means it doubled. So y would have to halve from 10 to 5. Okay, right. So I'm going to stop the video there. It's relatively long now. And I guess I'll put it maybe here.